Hello, so we're looking at the module 3.4 Ready, Set, Go. For the Ready, on the formative, they give you a couple of true-false questions. So you just need to kind of go through and ask yourselves, can linear and exponential functions both be discrete or both be continuous? Or is one discrete and one is continuous? Do they both have a domain and range? Are they always increasing? Are they always decreasing? These are the kinds of questions that will be for the first chunk in the Ready, Set, Go. For the set, we are looking at domain and range and whether or not a graph is increasing or decreasing. So this example is done for you in the formative, but I wanted to go over it with you so that it makes sense. So domain, if you remember, is the width of a graph. So over here I wrote domain and then I wrote arrows from left to right. So anytime I'm looking for domain, you're basically cropping your graph and you're finding how wide is it. So I'm going to find the leftmost point in my graph, which is right here. And then I'm going to write that down. So this is the point -1, -2, -3, -4, -5. So -5 is the leftmost point. And my rightmost point is right here at +2. So that's the hard part, right? Finding the leftmost value and the rightmost value. And then you look at that point. Is that point a closed dot? If so, closed dots always get brackets to show that that point is included. And then this point is an open dot. So that's going to be a parenthesis showing that that's a boundary. So that's your domain. It's your width. Okay. Then your range. Your range is your height. So I'm going to find the lowest number in my graph. Looks like I'm getting -6. And then the highest point in my graph, and that gives me +5. And then when I look at this point -6, that one has an open circle. So I'm going to need a parenthesis for that. And +5 is a closed circle, so that gets a bracket. So closed circle gets brackets, open circle gets parentheses. And then if you're looking at this graph, you have to decide, is this graph increasing or is this graph decreasing? And this one gets a little bit tricky, but you always look from left to right. So I'm going to start at the leftmost point and I'm going to say, is this line from here going down or going up? And this one is going down. So this one is decreasing. So you're going to use that example and you're going to do the exact same thing for problems 5, 6, 7, 8, 9, 10, 11, 12, and 13. And then just a little heads up, anytime they give you an arrow, that isn't, it's going to be infinity. And infinity always gets a parenthesis because infinity isn't actually a number, it's just a concept. And so we're going to put a parenthesis there because we're not going to stop at any number because the line goes on and on forever. And then the go is helping you remember how to write equations. So the first 3 in the go are done for you, but I'm going to do them again with you just in case you need an example. So first thing we need to do to write an explicit is find the starting output, which is 3, and the action, which it looks like 3 plus 2 is 5, plus 2 is 7, plus 2 is 9, so my action is 2. So I'm going to say f of n equals 3, starting at 3. I add 2, and then this one doesn't start at 0, it starts at 1, so I'm going to say n minus 1 times. That is my explicit. And I'll color code my equation for you. N minus 1 because it started at 1. 3 was the starting output. And 2 plus 2 is my action. So my recursive is saying f of n equals f of n minus 1, action, plus 2, Starting at 1, it was 3. So for the next example, I'm going to do the recursive first because it gives us all of that good information. Let's find the action. From 4 to 8, I could add 4, but then if I added 4 to 8 again, I wouldn't land at 16. So it's got to be times 2. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So this one is geometric. So f of n equals f of n minus 1. Action is times 2. And then starting at 2, the output is 4. So starting output is 4. Starting input is 2. So I'm going to do n minus 2 in my explicit. F of n equals, starting at 4, I multiply by 2 to the power of n minus 2. All right, last example. Find the action first. This one looks like it's subtracting 4. And then notice that it has a starting input of 6. So that's going to be n minus 6. And a starting output of 23. So my recursive is f of n equals f of n minus 1 minus 4. Starting at 6, it's 23. So I'm going to use all those numbers to write my explicit. F of n equals, starting with 23, that's my starting output. I subtract 4, that's my action. And then since I started, my input is 6, I'm going to say n minus 6 times. Because if I work, that would help me get back to 0. Same thing here. This one started at 2, so it's n minus 2. And the starting output was 4. And those numbers are here. Starting output is 4. Okay. So those 3 examples are there for you on the formative. And then there's 3 problems left for you to do to complete the lesson today.